The Mikoyan-Gurevich MiG-17, NATO reporting name Fresco, is a Soviet-designed jet fighter that defined the early jet age of air combat. Developed in the early 1950s, it emerged from a strategic requirement to counter faster, higher-flying Western bombers and fighters that were rapidly eclipsing first-generation jet designs, though often overshadowed by more famous successors. The MiG-17 proved that aerodynamic refinement and pilot skill could challenge technologically superior opponents. Its legacy still matters because it reshaped close-in air combat doctrine and demonstrated that speed alone does not decide control of the sky. The Mikoyan-Gurevich MiG-17, NATO reporting name Fresco, is a Soviet-designed jet fighter that defined the early jet age of air combat. Developed in the early 1950s, it emerged from a strategic requirement to counter faster, higher-flying Western bombers and fighters that were rapidly eclipsing first-generation jet designs, though often overshadowed by more famous successors. The MiG-17 proved that aerodynamic refinement and pilot skill could challenge technologically superior opponents. Its legacy still matters because it reshaped close-in air combat doctrine and demonstrated that speed alone does not decide control of the sky. 2. Origin and development history. The MiG-17 originated in the Soviet Union and was developed by the Mikoyan-Gurevich Design Bureau. The program began in 1949 as an improvement over the MiG-15, which had already seen combat in the Korean War. The MiG-17 first flew on the 14th of January 1950 and entered service in 1952. Its purpose was clear: address the MiG-15's limitations at high subsonic speeds and improve performance against newer Western aircraft. Rather than replacing the MiG-15 outright, the MiG-17 refined and extended its design, eventually becoming one of the most widely produced fighters of its era. 3. Design philosophy and airframe. The MiG-17 followed a philosophy of evolutionary improvement. Its airframe retained the basic layout of the MiG-15, but introduced a more highly swept wing, 45 degrees near the fuselage and 42 degrees outboard to delay compressibility effects. At transonic speeds, the aircraft was constructed primarily from aluminum alloys, with conventional riveted structures typical of the period. The fuselage was slim and cylindrical, optimized for speed and climb, rather than internal volume. Visually, the sharper wing sweep and longer fuselage distinguish it from its predecessor, while technically the improved aerodynamics gave the MiG-17 superior high-speed handling. 4. Engine and propulsion system. Early MiG-17 variants were powered by the Klimov VK-1 turbojet, a Soviet-developed engine based on the British Rolls-Royce Nene. 5. Speed and flight performance. The MiG-17 was capable of a maximum speed of approximately Mach 0.93 to 0.95, depending on variant and altitude, translating to around 1,145 kilometers per hour, 711 miles per hour. Cruise speed was roughly 800 kilometers per hour. It had a service ceiling of about 16,600 meters, 500 feet, and a rate of climb exceeding 65 meters per second. While not supersonic in level flight, the MiG-17 excelled in sustained turns and high-altitude maneuvering, characteristics that later proved decisive in combat. 6. Range, endurance, and fuel. Internal fuel capacity was approximately 1,500 kilograms, giving the MiG-17 a combat radius of roughly 500 kilometers. Ferry range, with external drop tanks, extended to about 1,200 kilometers. External fuel tanks were commonly carried on underwing pylons, especially for transit missions. The aircraft did not have aerial refueling capability, reflecting the operational doctrines and technological limits of its era. 7. Fuel consumption and operating cost. Exact fuel consumption figures vary by flight profile, but the VK1 series engines were known for relatively high fuel burn compared to later turbofans. Historical estimates suggest fuel consumption on the order of several thousand kilograms per hour. At high power settings, operating cost per flight hour was never formally published, but by modern standards it was low in absolute terms, though demanding in manpower. Maintenance required frequent inspections and skilled technicians, particularly for the engine and gun systems, contributing to logistical complexity for sustained operations. 8. Avionics and sensor systems. The MiG-17's avionics were minimal and purely analog. Early versions had no radar, relying on ground-controlled interception and pilot visual acquisition. Some later interceptor variants, such as the MiG-17PF, were equipped with the Azumrada P1 radar, a mechanically skin set with limited range and resolution. There was no sensor fusion or automated threat awareness. Pilot workload was high, and effectiveness depended heavily on training and coordination with ground controllers. 9. Weapons and payload armament was centered on cannon firepower. Standard configuration included 137mm N37 cannon and a 23mm NR-3 cannons mounted in the nose. This heavy armament was optimized for bomber interception and proved devastating in close combat. The MiG-17 could also carry up to 500 kilograms of external stores, including unguided bombs and rockets, on underwing pylons. Later variants were adapted to fire early air-to-air missiles, but guns remain the primary weapon. 10. Stealth and survivability. The MiG-17 predates stealth concepts entirely. It has a large radar cross-section by modern standards and no infrared or electronic signature management. Survivability relied on small size, high maneuverability, and pilot tactics rather than technology. Defensive systems were limited to basic radio warning receivers on some variants. Its strength lay in agility, not concealment. 11. Real-world service and combat use. The MiG-17 saw extensive service across the Warsaw Pact, Asia, Africa, and the Middle East. It is most famous for its combat role during the Vietnam War, where North Vietnamese pilots used it effectively against U.S. supersonic fighters. In close-range engagements, the MiG-17's turning ability allowed it to score victories despite lacking missiles or advanced sensors. It also served in numerous regional conflicts, often as a fighter-bomber. 12. Cost, production and global impact. More than 10,000 MiG-17s were produced, including licensed versions built in China and Poland. Unit cost figures are not precisely documented, but the aircraft was inexpensive relative to Western counterparts. Its widespread export reshaped air power balances in developing nations and influenced Western fighter development, particularly renewed emphasis on dogfighting skills. 13. Strengths and weaknesses. The MiG-17 excelled in maneuverability, simplicity, and ruggedness. Its weaknesses included limited avionics, short range, and vulnerability to beyond visual range combat. As technology advanced, these limitations became decisive, but within its design context, it was highly effective. 14. Final verdict. The MiG-17 Fresco represents a pivotal moment in aviation history, where aerodynamic mastery met the realities of jet combat. Though obsolete by modern standards, it proved that thoughtful design and skilled pilots could offset technological gaps. Its legacy endures as a reminder that air warfare is shaped as much by doctrine and training as by speed and sensors.